Tesla's Optimus Gen 3 could end up becoming the most advanced humanoid robot ever built. Something far beyond a helper robot, and maybe closer to a machine capable of reshaping entire industries. Elon Musk recently made one of his boldest claims yet when he suggested that Optimus could eventually become a self-replicating system, almost like a von Neumann probe. The idea is simple but mind-blowing. Build one robot, and that robot could eventually create more robots, turning one unit into thousands without humans having to do anything at all. If that vision ever becomes real, factories could run themselves, countless jobs could disappear, and Earth could be filled with tireless humanoid workers capable of everything from folding laundry to constructing buildings. And Musk's ambitions stretch far beyond the planet. He imagines deploying these robots in space, mining asteroids, assembling orbital platforms, and even preparing Mars for human arrival long before we get there. As the world's richest person and someone who has already poured billions into this project, Musk clearly sees Optimus as far more than a simple assistant. That leaves everyone wondering whether TeslaBot is just another household gadget or a machine capable of redefining human civilization. Musk insists that the scale of Optimus will dwarf every previous technological product, even smartphones. At the same time, the rise of humanoid robots has made the question of whether machines will take our jobs feel more real than ever. Musk himself fueled the debate by posting that AI and robots will eventually replace every job, turning work into something optional, like gardening or cooking for pleasure instead of necessity. The comment left people both excited and uneasy. Humanoid robots have been appearing in rapid waves across China, Europe, and the U.S., but most of them still struggle with awkward walking, clumsy movements, or limited battery life. Tesla's robot, however, is the one everyone takes seriously because it seems to strike the best balance between design, capability, and practical engineering. It may not be the pinnacle yet, but after Tesla's shareholder meeting, it became the center of global attention. Musk has made dramatic predictions about the robot's potential, claiming it could work non-stop, never tire, and contribute to a future where human survival no longer depends on traditional labor. Tesla wants to produce these robots in such massive quantities that they might one day be more common than smartphones. And Musk believes this technology could even eliminate poverty as robots take over hard labor, dangerous jobs, and everyday tasks with unmatched efficiency. Even though he hasn't provided a clear business model for how individuals might earn money using Optimus, Musk has hinted that a robot like this could easily pay for itself through the work it performs. Tesla has already tested Optimus serving food in their own diner, which proves it can generate real economic value. If a future model costs around $50,000, its labor could theoretically pay off the investment in just a few years. Beyond income, Musk envisions Optimus as a tool to dramatically improve healthcare worldwide, including the possibility of becoming a highly skilled surgical assistant, or potentially even surpassing human surgeons entirely. Tesla's advantage comes from the fact that its cars have always been robots on wheels. They already contain batteries, motors, gearboxes, connectivity, AI vision, neural networks, and advanced control software, essentially everything a bipedal robot needs, just arranged differently. Tesla also has a global infrastructure for autonomous operations and manufacturing scale that no robotic startup can match. This is why Musk repeatedly says that Tesla is already the world's largest robot manufacturer, even before Optimus reaches mass production. While nothing on Earth currently exceeds human intelligence or capability, Musk is betting that Tesla can build a humanoid machine whose movements and behaviors operate with nearly human-like grace and precision. That idea naturally triggers comparisons to science fiction nightmares, but Musk frames it differently. Imagine a robot that behaves like a perfect assistant, capable of handing you a drink, cooking your meals, handling chores, or providing support as you age. That's the near-term reality Tesla aims to deliver when Optimus Gen 3 arrives. Unlike many Chinese humanoids that drain their batteries quickly or collapse once power runs out, Tesla is focused on endurance. Musk believes Optimus will eventually achieve 5 times the annual productivity of a human because it can operate continuously, either on its internal pack or by staying tethered. The robot's new battery technology is one of its biggest leaps. Early prototypes use modest packs around 2.3 to 2.5 kilowatt hours, enough for basic demonstrations, but not suitable for real work. Optimus Gen 3, however, will reportedly use Tesla's 4680 cells in a roughly 6 kilowatt-hour configuration, giving it up to 14 hours of continuous operation, something no other humanoid robot has achieved. Gen 3 also moves with such smoothness that Musk says people will need a poke to confirm that it's not a human in a suit. On top of that, Optimus automatically recharges itself. Instead of being plugged in manually, it navigates to a charging station, aligns its connector, docks, charges, and then resumes work. This level of autonomy is unheard of in the robotics world and showcases how far ahead Tesla is in integrating AI, energy systems, and robotics into one seamless ecosystem. Other companies, especially XPeng in China, are racing to compete. Their iron robot focuses heavily on lifelike design, synthetic skin, feminine proportions, and sociable appearance. It uses a human-like spine, soft artificial muscles, flexible joints, and nearly human levels of motion freedom. It looks more like a digital companion than an industrial worker. XPeng is targeting service roles, tourism, retail, hospitality, while Tesla is focused on factory productivity and domestic labor. Tesla's 40 degrees of freedom may sound simpler compared to iron's higher complexity, but Tesla invests its sophistication where it counts, in the hands, wrists, and vision-based manipulation skills needed to perform real-world tasks reliably. Where Tesla pulls far ahead is in AI training. The company has millions of cars collecting real-world data daily, feeding enormous neural networks and refining physical world models at a scale no robotics firm can match. Optimus directly benefits from this entire pipeline. Its ability to imitate human motion, handle objects, or learn tasks isn't based on handcrafted scripts, but on the same powerful AI foundation that drives Tesla's full self-driving system. Optimus Gen 3 is expected to become Tesla's first true commercial model, capable of around 3,000 useful tasks, everything from cooking and cleaning to complex caregiving. Hospitals will likely adopt early units, and Musk believe the robot will eventually be capable of world-class surgical precision. The goal is to give people back their time by letting the robot handle the work that drains hours from daily life. Musk has often said that 3 obstacles make humanoid robots incredibly hard to build: dexterous hands, real-world AI, and scalable manufacturing. Tesla is positioned uniquely well to solve all 3 simultaneously. Whether Optimus will genuinely transform the world or simply become an advanced household helper remains to be seen, but the direction is clear. We are entering an era where humanoid robots fuck. Tesla's upcoming Model 2 has completely flipped the automotive industry upside down, and it's not just because of its shockingly low $10,577 price tag. The leaked development data reveals that Tesla has been testing 3 technologies so unusual for this price class that they're being called disruptive even by skeptics: a nearly unbreakable polycarbonate windscreen, a thermal loop frame that manages heat through the car's skeleton, and a weight-adaptive floor plate that changes how passengers experience comfort and safety. These aren't small tweaks. They're engineering swings big enough to ripple across the U.S. market. And if you're sick of recycled car news, this is where things finally get interesting. The first breakthrough comes from a Model 2's windscreen, a full structural upgrade that nobody expected in a budget EV. Drivers in states like California, Texas, Florida, and New York constantly face debris, temperature extremes, and daily stress that destroys traditional laminated glass. But Tesla swapped out standard glass for a 0.27 to 0.33-inch multi-layer polycarbonate laminate built from 3 synchronized layers: a flexible outer shell that spreads impact force, UV-stabilized core that maintains rigidity without becoming brittle, and a heat-reflective inner coating that cuts down thermal load before the AC even begins working. Instead of cracking upon impact, the polycarbonate flexes and deflects force, surviving situations where normal windshields fail. Traditional glass starts developing microfractures after around 80 to 120 hot-cold cycles, basically one harsh summer and winter. This polycarbonate handles more than 500 cycles without losing structural integrity. Gravel that would instantly chip glass simply bounces off the Model 2's flexible surface. The numbers are extreme, up to 160 times the impact resistance of tempered glass, capable of absorbing as much as 150 to 180 foot-pounds of force. Even under heavy impact,